And without further ado, I would like to introduce Dave Gavilek. Dave has been with Test Oil for over 10 years at this point. He came to us after he completed his studies in electrical engineering and economics at Cleveland State University. And since then, he's really played an integral role in the laboratory as a supervisor and then eventually our lab manager. And he's really helped us uphold and adhere to our ISO 17025 accreditation. And currently, Dave is a data analyst with Test Oil. So he's really looking at all of that data from the oil testing and making those technical recommendations and suggestions to our customers. And he partners with our reliability professionals to make those critical decisions on maintenance actions. He also holds certifications as an oil machinery analyst and a certified lubrication specialist. One of the other great things that Dave does with Test Oil is he's part of our Test Oil Industrial Services team, and they actually go out and work with our customers in order to pull samples using proper techniques and sampling best practices. So he's going to be really a great wealth of information on this topic since he does this pretty routinely. Given the coronavirus situation, obviously we're not traveling as much as we normally do, but we're able to at least stay healthy and stay safe while that's going on. And Dave, I will let you take it away from there. And it looks like you're muted if you want to unmute yourself.
Thank you very much, Heather, and thank you everyone for attending today's presentation. So like Heather said, my job as a data analyst has kind of dual roles. Sometimes I'm at the lab and at the office reviewing oil analysis data, and other times I'm out in the field and I work very closely with customers to not only set up their oil analysis programs, but I do some sample collection and work very closely with their inputting their work orders and managing their maintenance tasks. So I've seen both ends of this, and the purpose of this presentation is kind of to distill the knowledge from both sides to help you get the most out of your oil analysis program. So jumping right in, we've basically broken down sampling best practices into 5 sections. What we're going to talk about first is understanding why it's so important to take good samples, and then we'll move on to how to select which equipment to sample and where to pull the samples from. And then I'll walk you through some of the tools available to help take good samples and develop good sample taking procedures. And once we've covered that, I'll wrap up with a brief discussion on sampling frequency. And that should give us the why, the where, the how, the what, and the when of sampling best practices. So if there's one thing I want you to take away from this presentation, I would say the single most important factor in oil analysis success is consistency. So in the most general terms, oil analysis is monitoring data to allow us to see what is normal so we can tell when something is not normal. Oil analysis is a little different than other PDM technologies such as thermography, vibration, and ultrasonics, because those technologies all have very well-established patterns and formulas and thresholds to set the alarm limits. But when it comes to oil analysis, every machine and lubrication system is unique. And there are essentially infinite variables that go into a complex system, such as a piece of rotating equipment. So consistency in sampling is how we can keep our signal to noise ratio good enough to get good, consistent, repeatable data that allows us to establish what is normal so that we can see when something becomes abnormal. So normal can only be established by taking a sample that's going to provide you with useful information. So it has to be representative of 2 things. Firstly, what you're monitoring, what your area of concern is, and secondly, the true conditions of what that is that you're monitoring. And we'll cover this further as we go into the presentation, but your area of concern or your goals could be related to either extending the oil drain, keeping the oil free of contaminants, or predicting failures, or likely a combination of all those things. If the sampling is being done inconsistently, that's going to give you inconsistent data, and it's going to dilute your signal to noise, which is going to cause you to either miss signs of a problem and incur unscheduled downtime, or conversely, it could give you false signs of a problem, which cause you to waste time and energy kind of chasing your tail to find a problem that doesn't exist. So when you think about taking samples, with that said, it's entirely possible that you can take samples in such a way that you add way too much noise to the data and you're really not going to have an effective oil analysis for that specific piece of equipment. So in some cases, taking a bad sample is worse than taking no sample at all. But sampling from a decent or a good location, even if you don't have the best of procedures, is of much value. Really, the location matters a lot more than the procedure and is one of the harder things to change. So if you can get the location right, you can always work on the procedure later. So let me give you an example here of a hypothetical system. It's got some kind of reservoir and it's equipped with a drain valve at the bottom, and also somewhere within the system there are filters with ports at the inlets. So if you took a sample from the drain and you let it flush thoroughly for a full 10 seconds, or if you took a sample from the port at the return side of the filter and you just take the first fluid out of that port without any flushing at all, which do you think is a better sample? So assuming there's proper flow on the return line and everything's working as it should, even though the port wasn't flushed, the filter inlet is going to provide you with a much better sample because it's still giving you live circulating fluid. The drain, even though you flushed it thoroughly, is meant to be the resting place for all of the dirt and the water and the other particle contaminants. So even after thorough flushing, those things might still get into the sample. So unflushed filter inlet is an example of a great location with a poor procedure, and the drain sample is an example of a poor location with a great procedure. And the location does trump procedure. So the goal should be to establish great sampling locations, but if that's not possible, establishing good procedures to make up for this is the key. So sample point location. Sometimes you have to be practical and work with what you have because a great sampling location isn't an option, but creating a great sampling location is going to make all the difference in capturing useful, valuable data. So we're going to talk about how to get the best sample locations possible. Consider this statement. An effective oil analysis program should focus a thorough test slate and consistent sampling frequency on select pieces of equipment rather than a minimal test slate on all pieces of equipment. What this basically boils down to is you should be deliberate about where you place your resources. You shouldn't necessarily test all equipment, but there are some factors to consider here. There are 6 criteria to consider when selecting which equipment to sample. And if a piece of equipment meets any one of these, it's probably worth sampling. So firstly is criticality. When you say a piece of equipment is critical, that means if it shuts down or ceases to operate at its full capacity, the entire process incurs downtime or reduced output or reduced efficiency. Or it's possible its failure could cascade and cause other things to fail. So if it's mission critical, you want to sample it. And secondly is safety. And what I mean by safety isn't that if it fails, there's a chance that someone gets injured, because that's the case for most pieces of routine equipment. But what I mean is that, is this machine a piece of equipment designed to encourage or enhance safety, such as an emergency braking system on an elevator or a backstop on a conveyor, or is it a pump on a fire water suppression system? These are the kinds of things that you need to work in the rare instance that they're required, God forbid. So safety equipment is well worth sampling. Expense. If it's expensive, whether that be from downtime or labor or parts, it's probably worth taking oil samples. Some of my industrial services customers have various pieces of equipment, compressors and pumps and things that are 50, 60 years old, and they sample these monthly, and they pay a lot of attention to the data because they can't find off-the-shelf components to repair these. If any of these machines fail, they have to, if they don't have them already, create technical drawings and have the components specialty machined for them, which can take at best days and oftentimes weeks. So if there's a significant expense that you're going to incur from anything, if this equipment shuts down, it's worth taking oil samples. And oftentimes the cost of one prevented incident from one machine could justify the cost of the entire program for years. Reliability is another factor. And what I mean by reliability basically is the unpredictability. If there are small components like pumps or gearboxes you buy that conversely, you can buy them right off the shelf and they're rated to last 8,000 hours and you know that you're going to get 8,000 hours or at least a solid years out of service, say. Like you've dealt with these for several years, you understand how they work, they're easy to fix and replace, and you know when they're going to fail, that might not be worth testing. But if you use components that are rated for a certain life cycle, say 20,000 hours, and sometimes they fail at 5,000 and sometimes they fail at 10,000, you have no way of predicting when they're actually going to fail. So this type of equipment that might not have high reliability is well worth sampling. Efficiency is another factor to consider when selecting equipment for sampling. Has the equipment been operating below normal efficiency or experiencing increased power consumption or showing other signs of abnormal operation? If this is the case, Murphy's Law says that it's probably not going to get better, and in case it will likely get worse if it's left alone. So this is a good opportunity for sampling to get some data to try and diagnose the cause. And kind of on a related note, if you have changed the duty cycle or put a piece of equipment under an increased load, you might want to start sampling just to keep an eye on it, even if historically it's been very reliable. So lastly, the environment is an important factor here. Does the equipment operate in a harsh environment? Is it constantly exposed to high temperatures or moisture, or is there a lot of particulate in the air that's likely to get into the system? We know fluid cleanliness is one of the most important factors of equipment health. So if it's in an area in which it's frequently or constantly exposed to high levels of stress and contaminants, it is well worth sampling and monitoring. So to recap that, success in oil analysis depends on consistency, and consistent data will be acquired by using a consistent sample location. Now, the sample location should actually be determined by the goal or goals of the program or for that specific machine. There are primarily 4 goals in any oil analysis program. There could be others, but these are the 4 that are most common that I've come across. Firstly, you want to extend the oil drain to reduce consumption or reduce the cost of lubrication changes or lubrication-related PMs. Secondly, you want to monitor the cleanliness. Thirdly, you want to extend the component life. And lastly, you want to predict and prevent failures. So your goals are going to determine the ideal sample location for your equipment, and let me show you what I mean by that. This is an example of a very common lubrication system. It doesn't matter exactly what it's lubricating for this example, but it has a reservoir, 2 pumps, and 2 filters. There are a variety of places you can take a sample from in the system, and each of them is going to give you somewhat different information. So when it comes to the pumps, let's say it is absolutely critical that this lubrication system function properly, and if one of the pumps go down, it may or not compromise the function of the actual equipment it's lubricating. But you might also say that, well, there are 2 pumps, so there's some redundancy. We don't necessarily have to sample these. You have to make that determination. But if you were wanting to check the function of the pumps, you could take a sample right out from the pump outlet. And then each pump also has its own filter. So if you're very concerned about the cleanliness and you want to ensure the filters are performing correctly, it's possible you could take a sample from the filter inlet and then a sample from the filter outlet to see if the filters are functioning as per their rating. But then again, you might also say, well, there are 2 pumps and they both had differential pressure gauges. So, I'm sorry, 2 filters. They both have differential pressure gauges. It's not critical that we sample these because we have some redundancy. So, fair enough. And if you're more concerned about the condition of the fluid, or if you just want the general cleanliness of the system, you have 2 options to sample from the reservoir. You could pull from the drain, or you could drop down from the fill port. And lastly, you might not be concerned about the lubrication system at all. You might actually be concerned about the health of the equipment that it's lubricating. And in that case, if If you want to monitor system damage or system component wear, you could sample from the return line. So your goals are going to determine which of these are the best sampling location for you, and we're going to cover that in a bit more detail coming up.
Hey, Dave. So I received a question, and you might be coming up on answering this, but the question we have is, if I join an installation and I find that the samples have historically been taken from a less than ideal location, is it more important to be consistent with the history or get a better location established? I thought that was a good question for this part of the webinar.
Yeah, that is a really good question. So I would say there's not quite a simple answer to that, but if you were to encounter that situation, here's what I would recommend. I would take a sample from both, and then I would contact whoever's doing your testing and I would explain the situation. I would mark the samples very clearly so that the one from the historical sample location is identifiable, and then the one from the new location is identifiable. Contact the lab, send them in, and see what the difference in the data looks like. Once you see that, you can figure out if the new sample is going to make a better location as far as getting actionable data. So that's a really good question, and whoever asked that, good on you. And if you have any other questions, just let me know, Heather.
Yeah, I will. That I completely agree with you, what you said. From my experience as a data analyst, you know, you're going to end up having a more representative sample of what is actually in the system if you are using an optimized sample location. And obviously that trend is going to change a little, but over time, you're going to be really looking at better data in the long run. And it might be just you need to keep a closer eye on the equipment while you're in that transition period. But I completely agree with you.
And I would say, just to follow up on that, communication with your lab goes a long way. So even if you just write like a simple note on a bottle that says that taken from reservoir or taken from new drain port or whatever, that little tidbit of information is going to clue whoever's reviewing a report in that there might have been some change made. So communication is almost always good. So on that note, when we're selecting a sample location, it is important to note that different locations are going to bias the data a little bit. And what I mean by that is changing locations is going to change the information that you pull in regarding your component wear, particulate contamination, water contamination, your ferrous wear concentration, and then those are also going to impact the analytical ferrography. Things that probably won't be impacted so much by changing our sample location would be the physical and chemical properties of fluid, such as the viscosity. That should be consistent across the entire system. The acid and base numbers should be consistent. If we're talking about an engine oil, as far as the fuel dilution goes, the fuel is a solvent that'll blend with the oil and homogenize, so that should be consistent. And the same with glycol in the event that there's some sort of a coolant leak. And then the soot should be held in a homogeneous fashion by the dispersants. So none of those factors should be affected to a significant degree by changing the sample location, but the wear and contaminants will. So here on this slide are some of the true best practice sample locations, or the do's on the left. And on the right, we have what we consider bad samples or don'ts. And this boils down to any active flow area upstream of a filter is going to be a good sample location. Once we get down towards the bottom of that list on the left-hand side, the dipstick, it may or may not be a very good sample location. It depends exactly where it's located. Midstream drain samples, again, it depends exactly where it's located and what kind of a system it is. But those samples are still worth taking. If you're taking a sample from a dead leg and you're not able to get live oil, if you're taking it directly from a sight glass, or if you're taking it from a drain that can't be flushed. Those are samples you probably want to avoid. So the next few slides will include diagrams of common equipment types and kind of the order in which we would recommend various sample locations. So this is a pretty common splash lubrication gearbox. The ideal location is a sample valve with a pitot tube a few inches from the surface or a few inches below the surface of the oil, away from the wall and away from the gear. That's your number one. And then number two, your next best sampling location in this type of equipment would be the dipstick tube. And you're going to acquire a sample by dropping a length of sample tubing and using a vacuum pump through that. But you want to make sure the tubing length rests at a similar depth to the pitot tube. You want it to be a few inches below the surface and not scraping the bottom of the reservoir. In some cases, the dipstick tube doesn't leave you an option except to scrape the bottom. And if this is the case, this can be considered when assessing the sample results. Again, this is a good thing to communicate to your lab. If the only way you can extract a sample is to go through the dipstick and scrape the bottom and suck up all of the settled dirt and contaminants down there, that's helpful in assessing the sample. So your next best sampling location, or your number three sampling location, would be the breather or fill cap. Sometimes these aren't accessible because of the protective metal mesh that's underneath. I'll tell you, I see this very frequently when I'm out in the field. Don't punch a hole in these. These are meant to protect the oil, and they do a good job of that. They're inexpensive alternatives that will replace the breather that we'll talk about in a bit, but it's better to not destroy the protective mesh to take a sample. Let's say there is no protective mesh and this is a viable sampling location. When you drop a tube down into a gearbox, you have to be cognizant that they can get meshed into the gears. Be very careful that where you're dropping the tube is not going to interfere with the gear system. The next best location, our number four location, would be the drain, assuming it's well flushed. And then lastly, the last resort sample location on a gearbox would be the inspection cover of the hatch. And that's because this should never ever be open when the system is operating. Hence, it requires the equipment to be shut down, and that's likely not convenient. You'll notice we do have one more sample location with a question mark, and that's the sight glass. The sight glass is rarely an ideal sample location. If it's able to be flushed appropriately, it could be. So I didn't want to completely discard that option, but generally speaking, all you're going to get is the stagnant oil out of there. So you kind of have to weigh that out based on the particulars of the situation. Next, we have
another question from Emily, and she asked, does this mean that analog gauge branch tubes like pressure gauges are not appropriate sample locations?
Again, it depends on the particular of the tube and the gauge, but they could be. If you're actually able to flush them out appropriately and get live oil, that's really what you want. You want to get live oil. So if you're able to get live oil, they could be. If not, you might want to avoid sampling from there. In these upcoming slides, you're going to see some alternatives. And I might be interpreting your question a little bit incorrectly because some of these gauges have sampling tubes and things that actually kind of work with the gauge. You'll see what I mean a little bit. And if that's the case, that's fine if you have some kind of integrated sampling provision on the gauge. But otherwise, sight gauge or something like that, you have to be particular about the specifics because you just want to be able to get live oil.
Yeah, so it sounds like in summary, if you believe that you can get a sample that is representative of what is making its way through the lubrication system, that may be an okay sample location then.
Yeah, that's a good summary. Thanks, Heather.
Thank you.
All right, so this is a very common bearing system. The best location, again, is a sampling valve. In the case that that's not available, a drain for most bearings isn't a bad option. In smaller bearings, that might be the only option. Just keep in mind, you probably have to refill as you take the sample. The breather or cap is a possibility, but again, that might not be accessible. And then for a reservoir, such as might be found on a hydraulic system or a larger supply, again, the sampling valve with a pitot tube is the best option. You see the pattern here. With the breather as a secondary option, in this case, the hatch and the drain are kind of a close 3 and 4. You want to weigh the pros and cons of opening a hatch and exposing the system to airborne contaminants versus the better quality of the sample you're going to get there. You might notice that the hatch is a better location than the drain for a reservoir, but the opposite is true for the gearbox, and this isn't solely due to the safety factor of the gearbox. In a large reservoir with several hundred or several thousand gallons of fluid, you're going to have a much higher concentration of contaminants settle to the bottom, and it just isn't feasible to flush several gallons of fluid to get past that. Some reservoirs actually have a drain that's not at the bottom. They've got a drain, you know, several feet up, and if you have a drain right in the center of the reservoir, that's actually a very good sample location. So if you must take a sample from the hatch, you want to ensure the sample is taken from the same compartment and at the same depth each time. And one option to achieve this is to cut a pre-measured length of sample tubing and attach a clean weight to ensure the tubing doesn't coil back on itself out of over the surface of the oil or into a wall or a baffle. You can use a clean aluminum or stainless rod as well, to which you attach the tubing using either clips or bands. Rubber bands are a perfectly safe option. This way you can measure the rod and situate the tubing so when the rod contacts the bottom, the tubing is several inches higher and at an ideal depth for sampling. And I should step back and just say, if you are using some sort of a rubber band or a ring or something like that, just make sure it's compatible with the fluid. Some of these bigger systems have phosphate ester type fluids or other fire resistant fluids, and they're not all compatible with common rubberized materials. So one thing worth noting is when you do have a slightly more complex sampling procedure like this, this is where you want to have a short but sweet written procedure, especially if you have different people carrying out this task. And it can be as simple as something like cut a 24-inch length of tubing and clamp the weight on at approximately 18 inches, drop the tubing in the north compartment of the reservoir, fill the bottle and dump into the waste container once before filling for the sample. That's it. It doesn't need to be complicated. 3 sentences should cover it. So now that we've covered some of the preferable sample locations, I'm going to provide you with a survey of some popular sampling tools and provisions, aka sample valve ports, which can not only improve the quality of the samples and data, but will also save a lot of time and prevent contamination of the system. First, I want to talk briefly about the sampling equipment and consumables. Test Oil will send you free sample bottles, sample bottle labels, and sample tubing and vacuum pumps. And you can order these by phone, by email, on the DataSite portal website, and you can set up recurring orders, so you only have to do it once. So there's absolutely no need to do what you're looking at here. These are real samples that have been submitted to us, and these samples all had significant contamination issues. And talking about the signal to noise ratio of the data, you're not going to get a lot of useful data in a sample like this if you don't know if it came contaminated due to the storage. So it goes without saying, this is not a good consistent way to take samples and get repeatable data. And especially in this case, if you look at the ingredients of this Gatorade bottle, which is filled with an engine oil, the ingredients in red will all impact the test results. In particular, sodium citrate and monopotassium phosphate show up in the elemental spectroscopy data as coolant additives. And again, just to reiterate, there's no need to do this. Just contact us, and as long as you're set up in our system as a customer, we'll send you sampling supplies at no cost the same or next day. So the proper sampling provisions make a significant difference in the quality of a sampling program. They're safe, They're rated to handle high pressures and flow, and because they can be installed in so many different locations in a system, they eliminate the need to open hatches and covers, and they generally eliminate the need to move your body to an area that might expose yourself to hazards while you're sampling. They're simple to operate, so between that and eliminating safety concerns, it makes the individual taking the sample much more likely to follow a good, clean procedure, and they're convenient and save time, and they also don't expose the system to contamination. There are many, many types of sampling valves available for virtually all situations and types of equipment. And they come rated to various levels of pressure. They have adapters and bushings available to fit them to most all existing plugs, so you shouldn't need to tap in. They come equipped with seal caps to minimize contamination, and they're small enough that in complex systems where you might have multiple components you want to monitor, they can be installed, since they have such a small footprint, to monitor multiple locations. If you're going to run, I'm going to run through some examples of different types of sampling valves here. This will be kind of quick, but you should have the ability to circle back and review the recorded version of this if you want to check out the specifics. So first is the mini mesh style, and this is the most common type of sampling valve that I've encountered. These are inexpensive. They run around $30 for just the valve, and they seem to be very reliable. They're standard and high pressure varieties. They come with the cap attached, which seals with an O-ring. It's recommended to wipe the cap, and if it's exposed, wipe the face of the valve before sampling. They do require an adapter, and you can see the standard adapter pictured here with some sampling tube attached, as well as the push button attachment to the right of that. For high viscosity oils, if you're dealing with a gear system with something like ISO 220 viscosity or higher, these high flow mini mesh valves are recommended. The valve clearances are obviously larger and they're rated for lower pressures, but they operate basically the same, and these also require an adapter. Pitot tubes are an add-on to these types of valves. They're just stainless or aluminum tubes that attach to the inside of the valve to allow you to sample from a desired location a bit farther into a reservoir or whichever area you're sampling from. They come in rigid or swivel varieties. They're available in several lengths, and they can come pre-bent or angled. The ports and adapters for these are the same. The push button valves are very similar, but the adapter is attached to the valve. And they usually come with the drain at 90 degrees, which also comes with an attached cap. Again, make sure you wipe the valve cap and the valve when sampling. There's an inline T variety for attaching to tubing. There's also a flush mount style, which I've seen used for sampling. These are more generally intended for draining or filling, and they have a specific type of quick connect adapter, but they can be used for sampling. And to Emily's question, so there are sight glass sampling valve combos available, which incorporate the valve and pitot, which goes right through the middle of the adapter so that you draw a sample from an active area on the other end of the pitot and not through the sight glass. These are great. This type of variety pictured here extends out horizontally, so you have to make sure you have enough clearance, but these products are great if you do use sight glass or sight gauges. This one here is a drain mount style, which allows you to replace the drain plug. And these include, sometimes they include a level gauge. They include the sampling port with the pitot tube, so you're not actually sampling from the drain per se, as we've been referring to drains. You're sampling from somewhere on the other side of the pitot tube. And then on the right side, you see the drain tube capped off there. And then here's another variety that includes a level gauge. These aren't quite as, at least this variety here, this isn't quite as robust as some of the others, but this certainly does the trick and allows you to sample live oil while still monitoring the level. And here we have a tubing mount style. These are very handy if you have tubing lines, you don't have to modify any piping. They can be installed pretty quickly on the fly. And then here, this is what I think is one of the most useful varieties for sampling equipment. And I recommend these all the time. This is a breather style, and this variety here includes an air filter and a desiccant, so it's got a nice two-stage filtration. On the right side of the model, protruding from the side, is a vacuum pressure gauge, which indicates when the filter element is clogged, and it's time to change that out. This variety also includes a fill port, which is kind of on the far left side there, pointing away from the camera, and then the sampling port with a pitot tube extending downward. So these are designed to replace standard breather caps, and they're pretty much, for the most part, standard breather cap adapters. These fit right onto. As long as you have enough vertical clearance, these are a great option. They eliminate the need to open the system up, either to top off or to sample, and they keep the headspace clean and dry. And if all that fails, well, let me back up. There are some other styles I didn't list here. There are catch pipe valves, spacer flange valves, probolizer type valves. There's the bacon bomb or sample thief, which I didn't include. These are all viable options for sampling, but they're less common. The valves that I talked about are really the route you want to go. And if all else fails, a quarter turn ball valve is perfectly viable as long as it's in a viable, sufficient location. These will require some flushing, and I would recommend that you add a 1/4 inch 90 on the end and point it downward to inhibit contamination. But classic ball valve, perfectly viable sampling option.
So Dave, we have another question from Francisco, and he was asking and mentioned that some models of internal combustion engines do not have an established sampling port. It is understood that the oil return from the pump is in the crankcase once it has passed through the filter. Is it advisable to sample with a vacuum pump through the dipstick conduit? And to me,
go ahead.
No, to me, in those types of situations, you don't always have a choice. Sometimes you're just going to have to work with what you are capable of doing. This is obviously similar to a passenger car, right? And for our passenger cars, we do use the vacuum pumps or the suction pumps, or one of the other various names they go by. So Dave, I don't know if you have more thoughts on that.
Yeah, that's pretty much aligned with what I was going to say. On most mobile equipment and generators and combustion engines, you see the sampling done at oil changes. So it's just taken midstream from the drain. But if for some reason you're taking a sample when you're not changing the oil, that's the best option. I'll check with some of our engineers, some of our engine guys that might have a little bit more to add to that, and I'll get back to you, Francisco, but I would say that's a perfectly viable option.
Thank you, Dave.
Sure thing. So getting to the sampling tools, this is the type of sample pump that we will send you with your sampling supplies. And it's very simple to use. I'm going to add the laser pointer here just so you can see precisely what I'm talking about. So to use this, you just screw on the bottle right here. You have this here, this ferrule. You're going to cut the sample tubing to about a 45-degree, give or take. And you're going to feed it through the ferrule, and then you're going to tighten the ferrule around it. You want the tubing to sit about 1/2 inch below the bottom of the pump inside the bottle. When you put one side of the tubing in the bottle and seal it, and then you put the other side in the fluid, you create your vacuum. And then you just pull the piston back to create vacuum and draw on the sample. So just be mindful when you use these that it's very easy to splash sample from the bottle onto the bottom of the pump. And if you pump very vigorously or don't hold the pump level, that can pretty quickly lead to cross-contamination for the samples you do next. And like I said, angle cut the tubing. That keeps the splatter down. And also, the simplest way to cut the vacuum and stop the flow is just to unscrew the bottle, just a small fraction of a turn. You don't want to necessarily unscrew the ferrule or pull the tubing out of either the lubricant supply or from the bottle. If you pull it out from the lubricant supply, you run the possibility of suctioning up any debris or any contaminants that are floating on the top. If you pull it out of the pump, you're going to suction in some of the fluid from the tubing into the piston. So just keep it simple. Just unscrew the bottle a fraction of a turn, kill your vacuum, then remove the bottle, cap it, and discard the tubing. And then talking about sample tubing, we also send this to you at no cost. Do not reuse your tubing. It's extremely inexpensive. We'll send you more. It's not worth doing all the work to sample properly, only to reuse tubing and contaminate the samples. Since the tubing does come coiled, it tends to maintain that shape, and it will coil back on itself. So for sampling that requires longer lengths of tubing, like we discussed in reservoirs, you either want to have a guide rod or a weight like we discussed, or you want to cut and straighten this ahead of time. It's recommended to flush 1 to 2 ounces of fluid for each foot of tubing that you use, and you can actually you can flush the tubing in the sample bottle at the same time. So here's a pro tip: always have a waste container with you when you're sampling to flush not only the valves, but the tubing and the bottles as well. So now that we've selected the equipment we're going to sample and we've installed or acquired all the tools we need, let's talk about the best way to go about sampling. So just to rehash, the most important takeaway of this whole presentation: the usefulness of your sample data depends on the consistency of your sampling. So firstly, have a written procedure. Keep it simple, safe, and convenient. So I gave you an example procedure earlier. Here's another one. Use 16 inches of tubing to sample from the breather next to the supply line of the reservoir. Fill the bottle at the top line, discard, and then fill again to the top line for sample. That's it. Once you've established how you're going to go about doing it, the sampling itself is a fairly straightforward task, but you want to keep these points in mind when you plan your sampling. You want live oil. So if you must sample a piece of equipment that's not running, try to make it within 30 minutes of shutdown. And that kind of goes back to Francisco's question. You want warm, live, recently circulated oil. So if you are sampling from the dipstick, make sure you run that engine for a bit before you take that sample. Make sure your sampling area is clean. Know where you're going to put the cap of the sample bottle, for instance, when you're sampling, and make sure it's wiped clean first, because the analysis is going to show essentially anything that gets in the bottle, whether it was in the oil or it entered inadvertently. And lastly, flush thoroughly. Get past any buildup or water or stagnant oil. And this goes for the valves too. In that original example, when I told you to compare thoroughly flushed drain sample and a not at all flushed valve sample, you still want to flush the valve port. That's flushing a valve port thoroughly. That's in an active turbulent area. That's an example of using a great procedure at a great sample location, and you're going to get very high value data out of that. Okay, so here it is. After all that background, we get to the nitty gritty of sampling best practices. So the first step is wipe. Wipe the area near the sample valve, wipe the face of the valve if it's been exposed, wipe the area where you're going to place the bottle cap, and then flush. There are lots of different recommendations regarding how long to flush. Some people say 4 times the volume of the tubing. Some people say at least 10 seconds for a drain, and these are both good recommendations. But if there is any question, flush until the oil is hot. Then you know it's live. And fill. You want to fill the bottle only about 3/4 of the way. There's a top fill line on the ABS bottles, which is a great guide. You want to make sure you leave headspace, because the very first thing the lab does when they get a sample in is they shake the bottle to mix it up properly before testing. Then the next step is cap. You want to cap the bottle and tighten it. A firm, snug hand tightening should be sufficient for the bottle lid. Imagine giving like a stuck pickle jar just a firm turn. That's really all you need. This should go without saying, but make sure the sample bottles are labeled. If you don't have bottle labels, which again, we will supply for you, we'll mail to you either pre-printed or blank, and we'll give you the templates as well if you want to print them yourself. Any type of identifying information and the date the sample was taken is helpful. So make sure there is some type of identifying information on the sample bottle lid. And lastly, send. Just submit the samples for shipping. We turn around the sample results on the same day that we receive them. And the more recent the data is, the more relevant and actionable it's going to be if it's abnormal. All right, so to close out the presentation, I just want to touch briefly on sampling frequency, because this is one of those things that you can make more complicated than necessarily needs to be. So this slide is a chart from a study done on the efficacy of bearing fault detection using vibration analysis. And although this is a slightly different beast, the takeaway from this is that there is a sweet spot in timing up the frequency of condition monitoring. You could think of this as the Goldilocks principle. In this case, the sweet spot for bearing fault detection was 30 days. That was the highest value increment. The sweet spot for oil analysis, generally speaking, is between 30 and 90 days. There are some documents out there that are available which offer guidelines that have more or less become industry standards for sampling frequencies. This chart is from the Basic Handbook of Lubrication. Another that I'm not going to show you, but is commonly referenced, is ASTM D6224, which is the standard practice for in-service monitoring of lubricating oil for auxiliary power plant equipment. Now, even though the title states that it's for auxiliary equipment, it covers a pretty wide breadth of equipment types, and those recommendations are similar to those here in this chart, and they're good guidelines, they're good starting points. Now, that said, guidelines are a starting point, and the frequency of your sampling depends on several factors that you need to consider, and you should consider carefully, especially when it comes to the things we talked about earlier, like the criticality of your equipment, safety concerns, costs, and really just think about what it would mean if you were to incur a failure of a specific piece of equipment. The recommendation I make to new customers who have never carried out oil analysis is to first establish a baseline. You want to figure out what that normal state for your equipment is. So very first foray into oil sampling, sample your critical equipment monthly for 3 to 5 months, and then assess how stable the equipment seems to be, and then if it seems feasible, back off to quarterly or even biannually sampling for some equipment, and equipment that seems like it might incur problems in the near future, continue sampling monthly. As long as the dates on the sample bottles are accurate and undated samples aren't sitting on shelves or desks for weeks or months before they arrive to the lab, we can factor in any changes or inconsistencies in the sampling frequencies or the increments of time. What's most important when you first start out is that you figure out your baselines. So in summary, proper sampling is the foundation to success of oil analysis, and the sample point location should be specific to what you're trying to monitor, and it should get you high value data that's going to help you monitor that. The sampling hardware can improve the value of the data. It can make it safer and easier to sample. Procedures don't need to be complicated, but they should be consistent. And then the sampling frequency is going to be unique to each piece of equipment. It just needs to be often enough. So that wraps up the presentation. Those who submitted questions, those were excellent questions. And like I said, I will reach out to you if I'm able to get any more information. This last slide has Heather and I's email addresses and the phone number at the Test Oil Lab. And Heather, do you have anything else to add to close things out?
You know, we do have one last question from Emily, it looks like. And her question is, if it takes a week to get all the samples and they all get sent off together the next time we are in port, does the difference in age between the samples or the delay before sending them make a difference in the results?
No, I would say a week is fine. What I was referring to was more samples get accumulated over several weeks or several months, and then they all get sent in together. And most importantly, if you just write the dates the samples were taken on the bottles, then we can account for any discrepancies. Unless you are actually sampling every week, and then you only send them in once a week, that might throw a little bit of noise into the data when trying to decipher it. But no, I would say collecting over the course of 1 week and then sending them out together when you're back in port is perfectly fine.
Yeah, I would agree. The only other point on that I can think of is you want to try to keep these samples in a cool, dark, dry place so they're not exposed to the elements basically while they're waiting. Sunlight is known to cause degradation of lubricant over time. A week is probably not going to be affected, but as long as you just store them in the box somewhere that's not in a damp location, if you can, your office will be okay. So I would just keep environment in mind as well.
Yeah, that's a really good point. Thank you, Heather.
So, but otherwise, that was our last question. So Dave, I want to thank you very much. That was great. And you had a lot of really good information in there. The recording of this will be made available to everyone later today as I get that sent out. Otherwise, if you have more questions, as Dave mentioned, please always feel free to get in touch with us. We like chit-chatting and talking, as you can probably tell. And otherwise, any other information, we do have a blog on testoil.com. You're more than welcome to go and search, see if you can find some additional information. And everyone, take care, stay safe and stay healthy, and hopefully we'll talk to you soon. All right, thank you.
Thank you, everybody.